Okay, guys, we're going to learn how to add and subtract radicals today. All right, we did multiplication and quotient, division. You know, that was pretty basic. You just did the operation and simplified. Add and subtract is a little bit different, but not difficult. It basically involves simplifying, and then it's very similar to your old friend combining like terms. Okay, that's basically what you are doing. They're not exactly terms, but combining like terms, or in this case, it's what's underneath inside the radical. Those have to be the same, and those are called radicands, actually. Combining like radicands. So you can see in this first one, we have 2 radical 6 plus 3 radical 6. As long as these numbers inside the house are the same, then you can just add what's outside the house or subtract what's outside the house. Okay, so that's where it's like combining like terms, right? You can only combine things that are all apples or all oranges. So in this case, our answer is going to be 2 plus 3 is 5, and then we keep the 6. It's not 12, it's not 36, it's just 6. Okay, it would be just like if you had 2x plus 3x, you would have 5x, right? So same kind of idea here. The next one, the 3's are the same, so you can combine what's in front of them. Now, you do have to note that if there's nothing in front of it, it's a 1. Just like if it were x plus 5x, we would do 6x, right? Because there's an invisible 1 out front there. Same idea here. 6 radical 3. The 3 stays the same, okay? This just transfers into there. You don't add it or anything, okay? So then if we look at something like this, we can see that we have 3's here, so we can combine those, but we cannot combine the 4 radical 2, and we can't simplify the radical 2. So our best answer for this is, remember there's a 1 out here and a 1 out here, so our best answer is 2 radical 3 plus 4 radical 2. You will see more of those tomorrow. We're going to practice some more of those tomorrow, but I just wanted to show you that you can't combine anything that doesn't have the same number in the house. Okay, and so it's perfectly fine to leave that as your final answer. All right. Okay, and again, it's similar to if we had y plus 4x plus y, we wouldn't be able to combine all of it, right? We would do 2y plus 4x. That would be as good as we can get it. Okay, so that's kind of just a little bridge there to help you think through that. Now, of course, they're not all that easy. Of course, they're not always the same thing in the radicand. However, we can simplify them like you did the last couple of days. And once you simplify them, then if you have the same radicand, you can combine them. You can simplify them further. So obviously, you know what? I meant to make this a 45, not a 48. Sorry about that. That should be a 45, okay? So looking at that, I can't simplify that radical 5 any further. However, I can break this radical 45 up into a perfect square of 9 times 5. And you can probably already see why that is going to work out very nicely, right? So I can simplify this to 3 radical 5 plus radical 5, and I've got the same number now in the radicand, okay? So I can go ahead and add the numbers that are out in front there, and that is going to give me 4 radical 5 as a final answer. And I'm going to move these guys all down a little bit to give myself some more space. Oops. Bear with me for a second. Move these down. Oh, why won't it let me move them down? There we go. Down here. Give me some more space. Okay. So that's my final answer. 4 radical 5 is my final answer here. Okay. So what you're doing is you're going to simplify first. First, you're going to simplify. and then you're going to combine. Okay, those are your steps. So for this next one, and you get kind of clues on this, guys. If I've got radical 8 and I'm trying to go to 3 radical 2, then you can, like, I'm probably going to get a 2 out of that 8, right? So when I go to break it down, I'm thinking perfect square times radical 2 plus 3 radical 2, and I've got my matchies here, right? Now, a couple of you were struggling with this, so I'm going to show you. Radical 4, okay? If I want to suck that out of the radical sign, I can take away the radical sign if I take the root, okay? So in essence, and I'm going to erase it here so that you can see it, this 4 is, when I take it out of the radical sign, it poof becomes a 2, okay? I don't know if that's the best way to show you or not, you know, that this radical 4 becomes a 2. Okay, when I take it out of the radical sign, because 2 is the square root of 4. So now I can add 2 plus 3 is 5, and my radical 2 stays the same. Okay, and there's my answer. Let's do some more for practice. Probably going to have to move this guy down here a little bit. Okay, so now I'm going to reduce 20. I'm going to go through my list of perfect squares, and I know that 4 is a factor of 20. So now I have to take that 4 out of the radical, and when it comes out, changes its clothes. It's essentially just its root now. 2 square root of 5 plus 4 square root of, and I'll tell you what, I'll make these 5s the same so that you can see that that was my goal, right? I got radical 5s for both of those. So now I can add 2 plus 4 is 6, and I keep the radical 5, and there is my answer. Okay. Now, I don't know if you have to do some of them on your homework. I might do one from your homework so that you can see. Let's do one more here. This 12 is going to, this will be a good one to do. 5, I'm going to break this 12 into radical 4 times radical 3 minus 6 radical 3. Now, when I take the 2 out of here, when I turn this into a 2, I have to multiply it, right? I have to multiply it times that 5. I know my dot is not in a good spot there. I'm going to multiply that, okay? So don't forget to do that. A few of you had a little trouble with that on the quiz. Okay, that becomes a 2, but then it has to be multiplied by the 5. And so then you get 10 radical 3 minus 6 radical 3. 10 minus 6 is 4. Radical 3 is my final answer. Okay. Yeah, this will be a good one to do over here. Square root of 12 minus square root of 48. Sometimes you got to simplify both of them, right? So this is going to be square root of 4 times square root of 3. Minus, this one's going to go to, let's see, 16 is going to be my biggest square root out of there if I want to take the shortest route. 16 times 3. Okay, so now I have to take it another step. The square root of 4 is 2. Keep the radical 3. The square root of 16 is 4. Keep this radical 3. Okay, now I've got 2 minus 4. I need to keep change, and my final answer is going to be negative 2 radical 3. Okay, so sometimes you have to simplify both before you can do anything. Okay, and don't forget to use your integer rules. They still apply. Integer rules, keep change, whatever you have to do. Okay, be real careful with that. Okay, so good practice for simplification. Write those perfect squares down the side of your paper, or pull out an old list that you have to make this a little bit easier on yourself.